Okay, hello everyone, this is my small garden, and I'd like to show you how I have implemented the Internet of Things, so how I've connected my garden to the Internet and used principles of the Internet of Things to control certain aspects like watering and monitoring. So yeah, it's how I apply my hobby is gardening, growing plants, so some fruit, tomatoes, chili peppers, and some of the fruits, they prefer a warmer environment, and in the UK to provide that we need to provide a microclimate using a greenhouse, or in my case a polytunnel, a plastic tunnel. So if we have a look inside, I can show you some of the plants. So for example, there are some chili plants there, chili peppers, starting to get to a nice size there, and you'll notice that each of those plants has its own water dripper, so they're all connected to a water pipe, a water system, and the water system is connected to all the plants in this polytunnel. So on that side we have some tomatoes, and there's a strawberry, but each one has a water dripper. So I have three water circuits in this polytunnel, one for the baskets, and then the next one is for the ground plants. So for example, these are more different varieties of chili peppers growing in soil pots, and here I water the trays. I fill the trays, and the pots soak up the water, and then for example, I've got on the same water, I've got some that's a cucumber plant in the corner there, and you can see again the pipe is coming from the water system, and will fill up the tray which will water the cucumber, and that's a tomato. And for example, here I've got more dripper systems going into the ground, one here to water some basil plants, and under here there's a water dripper, and this is a aubergine or eggplant, and this has a small sensor which measures the resistance, the electrical resistance of the soil. So it's an inexpensive sensing device. It does have a small circuit, so you have to supply it with power. So I'm using these colourful wires, colour-coded wires, to supply the power and then take the signal back to my microcontroller. So what it does is it measures the resistance and produces a voltage which is applied to the circuit here, and this circuit goes back with five other moisture sensors, and they're all connected to this device here. So this device is a microcontroller called an ESP32. I'll talk a bit later about that. But the good thing about that is it has lots of analog inputs which can measure the voltage from multiple sensors simultaneously. So you'll notice there's multiple cables coming down here. So yeah, here's another example in one of the baskets. Got another moisture sensor, and that's going back into another of the connections on the microcontroller. So the microcontroller is powered, but it's not connected to any network by wires. It's a wireless device, so it has onboard Wi-Fi or wireless connectivity, and that is connected using encrypted Wi-Fi to a device in my potting shed, my shed in the garden, called an Arduino, and this collects all the data and sends it to an application or a platform called UBDots. So how can I see this data? Well, I can go to the application on the internet, so if I open the application here, and it's just refreshing. So this is free to use for education, and you can create what they call widgets, which are parts of the interface for the application, buttons, and at the bottom there, I'll try and get it into focus, it's a graph, and the graph is showing the values for the moisture for the 5 different sensors in the polytunnel. So you can see that it's a line graph, and each line is color coded, and they're reading values between 4 and 7 currently. So basically I've scaled the moisture values between 0 and 10, where 10 would be completely dry and 0 would be completely saturated. So you can see the values there are somewhere in between 4, 5, 6 and 7. And value 7, the highest one, is actually a moisture sensor, which is down there in the non-soil medium. So this is for a hydroponic system. It grows without soil. You put the nutrients into the water. So on this side, all these chili plants are being fed with regularly 4 times a day with water, which has nutrients added. So the moisture level there is 7 because this has a higher resistance. The clay pebble media has a higher resistance than the soil media that are being measured on the other devices. So yeah, how would I water it then? I can monitor the moisture level. I could have it switch on automatically, but I prefer to keep it manual. So again, if we look at my application, you can see there's a grey button, and if I click the button, I can hear a pump starting up, and we can see now the water starts to drip out onto all the plants. So that will carry on dripping and watering until I switch it off on my application. So that application is connected to the internet. I could do that from anywhere in the world. And I can monitor the moisture levels by looking at the graph. Okay, so just to, if you're interested how the water gets there, this is my potting shed in the garden, and that blue barrel is the water tank. So I collect the water from the roof, and you'll see the pipes coming out, two pipes one for the groundwater and one for the basket water. And there's two pumps. The pumps are supplied by power from the Arduino device inside the shed. The hydroponics comes from this green barrel, the green barrel on the left, and the reason that's different water is because it has to have the nutrients added to it. So that's on a timer. I don't manually run that because it runs many more times per day. So you can still hear the water being pumped. If I turn my interface off, there's a little delay while it connects to the internet, and you'll see it stopped. So the water stops dripping. It takes a while for the water to run out of the system, but it's basically stopped pumping it, so within a couple of minutes it will stop dripping. Okay, so if we look inside the shed, I can show you the other half of the system. So in here is the controller, if you like. So I could draw, we have an Arduino Yun, which is this device, and this has a Wi-Fi, and we have the polytunnel, and inside the polytunnel we have the ESP32 device, which has Wi-Fi, and this is connected to the moisture sensors. So this communicates using 802.11 Wi-Fi, and the commands it sends, the actual data is sent to a RESTful API, which is installed on the Arduino Yun. So the protocol it uses, you've got a choice of protocols, but I'm just using HTTP, which is a standard World Wide Web protocol used for all websites. Other options would be COPE or MQTT for IoT protocols. They have advantages. These are more efficient, more lightweight, but HTTP is more simple for my case, for my demonstration. Okay, so this device, how does it turn the pumps on? Well, you know, on top, this is the board on top is electrical relays, which are electronic switches. So the device sends a signal, a digital signal, when it receives the HTTP request from UBDOTS. That comes from the internet. So how is this device connected to the internet? Well, if we look at, this is what's underneath an Arduino Yun. This is my favorite device because it's got all my favorite platforms. It's got Arduino 80 mega microcontroller, so I can program that with C programming using the Arduino IDE. It also has a wired Ethernet port, but it also has a wireless interface, a wireless chipset, which supplies Wi-Fi, and that uses a version of Linux called OpenWRT, which you can configure to become a wireless access point and use other features of the Linux. For example, it's got a feature called a watchdog timer. So the watchdog can automatically reboot the system if it crashes. So that's useful. Otherwise, if you're running a computer system and it crashes or hangs, often you have to reset the power. So a watchdog timer enables the system to be rebooted or power cycled automatically. So it's a great device. You can see this is a Raspberry Pi, if you've heard of those. So it's a similar size to a Raspberry Pi and does partly the same job as a Raspberry Pi, because Raspberry Pi will run Linux. So you could create the same project with a Raspberry Pi and connect an Arduino to it. The advantage of the Arduino is you can easily program it to and connect it to these relay. So this is a relay shield which plugs into the Arduino, and you'll see the cables that come off from here go to, well, they're supplied power, because this is a separate power to power the pumps, and they go basically up through the shed wall. So you can see those connections, they're literally the connections straight to the pumps which are in that barrel outside. So that switches the pumps on and off. Okay, you may recognise that that's an Ethernet switch. So that enables wired Ethernet with copper patch cables, and I use that to connect the device by a wired interface to the house. Now the house is 25 meters away from the shed, so if I use wireless it's not very reliable, and I can lose the connection. So it's more reliable if I run a wire to the house and then connect the Arduino using that wire. So there you'll see the Ethernet going into the Arduino, and the other cable is just to power it. So that's all that needs to be connected. Okay, the other devices we have here, this is it's called a TTGo, but it's basically the ESP32 microcontroller. Again, this is the same device that I'm using in the polytunnel to collect or receive the analog inputs, the voltages from the moisture sensors. The moisture sensors look like this. So they're the probes that I'm pushing into the soil. These are other types of sensors. So this is a temperature and humidity sensor. So you could measure the temperature and humidity of the polytunnel. This is a proximity infrared sensor. So it can detect proximity of people, objects, animals if they move into the area, often used to turn on lights. So I could connect any of these sensors using a similar method. Okay, so in terms of cost, the ESP32 is literally just a few pounds, £3–4, and that's UK pounds, which are, you know, similar to American dollars, a little bit more. This is around about $50–60 American dollars or pounds, and that's a Raspberry Pi. They're around about 30. It's about half the price of the Arduino unit. The sensors, £1–3, you know, they're very inexpensive. So this is an inexpensive project, and no other computing is required apart from your connection to the internet, so a router, wireless router inside the house, or some sort of broadband or internet connection. Okay, so you need to have skills in computing to set this all up, in a little bit of programming. The programming code is not really complicated. It's fairly easy to follow and you can learn it in a short time. And networking skills to connect things up, and mainly to test, troubleshoot, fix problems. You need to understand how the networking is working. So I can demonstrate a bit of that and show you some of the security vulnerabilities of this system. If I go to my laptop now, this is just to demonstrate how you can monitor the system. It's not required to make it work, and in fact it's not plugged in to the network. If you see, the Wi-Fi is turned off, Wi-Fi turned off, so there's no internet connectivity to this laptop. Okay, but what it does have is a wireless dongle, which I can monitor the signals that are being transmitted, remember on my diagram, between the ESP32 and the Arduino Uno. Because this is a wireless connection, these signals are open for anybody to receive them. So Wireshark is a program which enables you to do that, enables you to monitor network packets as they travel either on wires or wireless. In this case, I'm looking at wireless frames with a wireless capture. So I'm using a USB dongle called an Air PCAP. Okay, so if I start the capture here, it says I've got unsafe packets, but we're just going to start a new one, and nothing happens to start with. So what would usually happen is when you capture the packets, they appear in this screen here. Okay, but with wireless they are encrypted. I do have a password on this wireless connection, and that password is used with the SSID, the name of the Wi-Fi access point. Together they're combined to create a pre-shared key, and that key is put inside the ESP32 so that they can communicate wirelessly. So this program Wireshark can actually decrypt those packets. I have to put the key in, okay, so I either have to guess the key or know the key, or there are programs that can be used to capture the key. I'm not going to do that, but it is possible. Okay, so what we're going to do is, at the moment, it won't capture anything because the key hasn't been sent by the ESP32. So we're going to go and reset the ESP32 and get that to re-authenticate with the Arduino Uno. So all I'll do to that is click the reset button, and you'll see it goes green. That light indicates it's connecting wirelessly using Wi-Fi, and when the light goes out, that means it's connected. So if we go back to the laptop, and restart the capture. We should capture. Let me try once more. I'm going to go back and reset the it is